Picture a billion-dollar factory. The turbines spin up to full capacity, the production lines run flawlessly, and the control room shows green across the board. The engineers celebrate a perfect build. Then, 30 days later, the company declares bankruptcy. How does a machine that works exactly as designed destroy the company that built it? It happens because making a plant physically run is only half the battle. Take a look at this structural arch. To achieve total project success, you need two solid foundations. On the left is technical project management. This team obsesses over timelines, Gantt charts, and engineering deliverables. Their single mandate is to build it right. But look at the commercial side on the right. This team operates in the background, managing capital expenditures, risk allocation, and vendor contracts. Their mandate is to make sure the plant actually generates a profit. If a project team ignores that invisible commercial pillar, the entire financial structure of the venture collapses. The technical achievements mean absolutely nothing if the business itself cannot survive. So how do we build that commercial pillar? We start with costing. And the first rule of costing is acknowledging that you cannot know the exact final price tag of a massive greenfield project on day one. This timeline illustrates how cost accuracy evolves. We begin with a phase 0 estimate, swinging wildly by 30%. It isn't until engineering data matures and detailed diagrams are finalized that we reach a definitive phase 2 estimate, narrowing the margin of error to 10%. Why do early estimates miss the mark so often? Because of what we call the costing iceberg. This cross-section shows the visible top layer above the water, direct costs like cement, steel, machinery, and manual labor. But drop below the surface and you find a massive hidden foundation. These are the indirect costs and financial overheads: bank interest, feasibility studies, corporate administration, and startup contingencies. Relying strictly on the visible materials to price a project guarantees a severe budget overrun. True financial survival requires calculating the entire hidden mass before a single shovel hits the dirt. Once we know the costs, we move to the second system, financial valuation. A profitable project looks far beyond the initial purchase price to determine the total cost of ownership. This diagram breaks down exactly how total cost of ownership is calculated. You take the initial capital outlay, add the ongoing operating and maintenance costs over the equipment's lifespan, and finally subtract the end-of-life residual value. To approve funding based on these costs, executives use a specific dashboard of metrics. The simplest is the payback period, seen here on the left. It asks one basic question: how fast do we get our initial investment back? Next is net present value, or NPV. This metric operates on the principle that money today is worth more than money tomorrow due to inflation. A project gets the green light only if its NPV proves it creates overall wealth greater than zero. Finally, we have the internal rate of return. This calculates the exact percentage yield where the NPV equals 0. If that percentage is higher than the company's cost of borrowing capital, the project moves forward. These metrics also drive operational strategy, like the make versus buy decision. This flowchart illustrates the rule. If manufacturing a part internally costs 100 rupees in direct materials and labor, and an external vendor sells it for 95, you buy it. These formulas serve as ruthless, objective filters. They exist to prevent companies from pouring capital into projects that would actively destroy wealth. All that precise financial math falls apart if the project is vulnerable to real-world chaos. That brings us to our final subsystem, the legal shield. Look at the anatomy of an enforceable contract. It operates through 3 interlocking gears. You have optional rights, standard duties detailing how work is performed, and binding obligations that mandate specific outcomes. These agreements function as a secure vault. They lock away a company's intellectual property, software logic, engineering drawings, and pricing budgets, ensuring competitors cannot replicate proprietary designs. Contracts also enforce the golden rule of risk. You can never entirely eliminate danger from a massive construction build. You can only allocate it to the party best equipped to control, mitigate, or insure against it. This risk matrix shows how that plays out. Contractors absorb the cost of design delays and errors. Owners, meanwhile, absorb unforeseen ground conditions. And extreme weather events, known as force majeure, remain neutral, granting time extensions without extra compensation. Modern contracts function as proactive, defensive architecture. They shield the timeline. the intellectual property, and the budget from the inevitable friction of a multi-year build. The commercial blueprint is a fully integrated engine. Sequential costing lays down the base, financial valuation proves the investment is sound, and strategic contracts provide the armor. When these commercial subsystems align, they rise up simultaneously to meet the technical engineering pillar, locking the entire project together into a single, stable structure. Bending metal and writing software only gets you halfway there. True engineering excellence demands uniting technical execution with commercial rigor to build an engine of lasting, undeniable wealth.